Good morning, everybody. Thank you very much for joining us today. There's a few more people we are waiting for, but in the meantime, I'm going to get going. I'm Nancy Gaucher. I'm the Knowledge Mobilization Specialist at the Water Institute at the University of Waterloo. I work with a number of projects that to support their knowledge mobilization needs. So that essentially means supporting co-creation efforts with knowledge users throughout the whole research process and working to ensure that the outcomes of the project are meeting real-world needs. I would also love to know who's joining us, so please feel free to use the chat box and introduce yourself. Maybe tell us what your organization is or your area of study. That would be really great. I want to start by acknowledging that we're participating on traditional territories of the First Peoples across the country. I'm in Kitchener-Waterloo, so I acknowledge that I'm on the Haldimand Tract, land that was promised to the Haudenosaunee of the Six Nations of the Grand River. The Haldimand Tract is within the traditional territory of the Neutral Anishinaabe and Haudenosaunee peoples. And through land acknowledgements, I hope that we can move towards reconciliation and improve our relations. Today's event is being hosted by Lake Futures, which is a 7-year-long multidisciplinary project that aims to develop adaptive watershed and lake management solutions that minimize trade-offs between lake ecosystems, water uses, and economic growth. In this webinar series, you will hear from select members of our steering committee, the Lake Futures Steering Committee. They're doing similar work or work that complements some of the research that's being done in Lake Futures. And the hope is through this webinar series that we'll learn what everyone's up to and be able to find opportunities to align or collaborate or leverage one another's work. So for those who are new to us, if you're interested in learning more about Lake Futures and some of our early research results, we have recordings of a webinar series that we did this past summer, and also one-page summaries, and those can be found on the Lake Futures webinar series website. I'll include a link to that in the chat box shortly. So quick logistics. The format today is we have 2 presentations. Ram is going to go first and then followed by Sandy. If you have clarifying questions or technical questions for Ram, we'll allow for a short Q&A period between those 2 presentations. So please, at any point in time, if you have questions, you can add those to the chat box. And at the end, we also hope to have a more thorough dialogue about like I said, the collaboration and opportunities between Environment and Climate Change Canada and also the organizations of our steering committee members and the Lake Futures research team. So like I said, feel free to add questions to the chat box. If you do want to speak, we might have some time as well for some verbal questions. You will be able to raise your hand and then we'll see if we have time to get to you. The raise hand, you should be able to click on the participants box and then you should be able to see the raise hand feature there. So I'll just introduce our speakers very quickly and then we'll move to the interesting part of the webinar. Ram Yerubandi has been with Environment and Climate Change Canada for the last 23 years in different capacities. He's currently the research manager in the Water Science and Technology Directorate, where he's responsible for managing and delivering research programs that are focused on water resources management, including impacts on freshwater hydrology. Before, he was section head of the Integrated Modeling Program, where he led programs that developed lake and river models looking at how climate change might impact hydroecology of aquatic ecosystems. Ram has a PhD in water resources modeling and is an adjunct professor at University of Toronto and Queen's. He's got over 110 peer-reviewed publications and many other academic and professional accolades. We also have Sandy. Sandy, thank you very much for joining us. I don't have a bio for her, but I'll just go on what I know. Sandy's the Great Lakes Program Manager or Coordinator for Environment and Climate Change Canada. I've worked with Sandy for a number of years now, and from what I see, she's plays a really critical role in connecting science and policy. So she has a science background, and but has somehow been able to navigate the policy realm. She's played a really critical role in the nutrients annex of the Great Lakes Water Quality Agreement, helping to set the Lake Erie phosphorus targets and write the corresponding action plan. And her work in interpreting science and helping to create nutrient policy continues as the government continues to work on Lake Erie, but also expands to Lake Ontario. I feel very, very lucky to have both of you present today and to learn from you. So without further ado, I'll let Ram take it from here.
Thanks, Nancy. Thanks for the introduction. And I'm going to go blind here to save some bandwidth. And I'm also actually glad to see that Sandy joined. Otherwise, I was thinking to talk about policy as well. Good morning, everyone. Thanks for this invitation. As I said, I think I'm the first slide, which basically introduces the title of the talk. But from this, you might be thinking that I could be talking about all the Great Lakes Protection Initiative work that has been going on from ECCC, which I have to say at the outset, I'm not doing that. I'm only going to talk about the excess nutrients in the algae work that our division or our directorate is doing mostly. I should say our directorate is doing. There are other things that are going on. For example, in the protection initiative, there is a contaminants piece there. There is a nearshore framework. Hopefully, Sandy will touch upon some of those things, but those are not my focus here. Okay, now I have to advance the slides. Okay, this particular slide shows that I'm just a face representing this group, very well-reputed folks from different areas, so both from science and technology branch. Sandy is there from the policy to help us. And then we have lots of collaborations over the years as part of this initiative, right from the academics to other organizations like Ministry of Environment and Climate Change, and then AAFC, and some other organizations as well. And I should thank all of them for providing the slides. And you may or may not see all of your work here because I want to finish this in 30 minutes and I had to cut many of the slides. The outline for today's presentation, as I mentioned, I will very briefly touch upon these research and monitoring activities that we are doing as part of this GLIPI, as well as when I say GLIPI, it's Great Lakes Protection Initiative. If I hope you might have caught this acronym already. We are also doing some work through the A-base work, and some partners work is also there within this presentation. I will talk both about the routine monitoring that happens besides this work that we are talking today, and also some of the focused monitoring and research activities in watershed and lake research and what we have been doing. But as I told Nancy and Sandy before, that the focus will be mostly on how we are doing this integrated modeling for water quality, which is essentially looking at process-based watershed modeling and how that links up with lake modeling. Finally, I will introduce the forecasting system that ECCC has, and I will not spend much time on many of these things, but it gives you some idea about what we are doing. Maybe for this group, probably this is not required because you're already initiated and you know why we are doing, but I thought there might be some students and others that just joined and may not have the full context of Great Lakes work. So I will briefly talk about this context here. The federal government does its work through two agreements. One is the Great Lakes Water Quality Agreement that some of you are familiar. The other one is we have an agreement with Ontario to address some of the work that that probably Sandy is going to present on the domestic action plans. So this Great Lakes Water Quality Agreement has been in place for quite some time. In fact, it's there since 1970s. And many of you might be knowing the reason for having this is, one of the reasons is the excess nutrients at that time. And there were already the statements like the lake is dead, the lake was dead, and all those type of things. Based on that, there were some regulations that were set up. I listed some, but there are so many other things going on, like both at the point sources and non-point sources. So that's where some improvements came. If you see that line on the chart there, that's at roughly at 11,000 metric tons. That's the goal that we wanted to get Lake Erie loading to the, and as you can see from that map, many of these years, we are actually meeting that goal, right? So the question will be like, if we are doing all these things, why the issue came back again? So as I said, there are conditions improving, and however, in the last 10 years or so now, because it's 2021, we already started seeing some reoccurrence of blooms and some fish kills happening, and some, the famous example is the Cleveland water treatment plant shutting down because of the hypoxic waters and the toxins that have been entered into these areas. So on the eastern basin, we have similar issues, but eutrophication related issues, but it's more on the benthic algae and very much in the near shore. So these are three different basins and three different issues and three different complexities in Lake Erie that led to the new agreement in 2012. So we have to see what the problem is. The problem is now a bit more complex than what a direct relationship between nutrient reductions to the algae growth. It's still there, but the other things are happening, like there's a lot of growth happening in the area, and then there is on top of it, you have changing climate, which results in the storm frequency changing and temperature changing and other things. We also had, from mid-90s, the increases are the invasive species coming in and changing some of the, so these are already, all these type of things happening simultaneously. So the management plans and the ways to respond to this also evolved. One of the key things that has been observed is the availability of bioavailable phosphorus or increases in those things from some of these tributaries, or most of these tributaries that are coming into the lake. Some people like Nandita and others are already addressing issues like the legacy phosphorus questions there. So for those of you, this is also, many of you might have seen this particular slide in many fashions, but this led to renegotiation and setting up new objectives in 2016, and how the countries, both Canada and the US, came together in addressing this particular question, right? The team evaluated, the team was established at that time. Sandy was our lead at the time, and she's focused on getting this algae control by setting some targets, like how much reductions are needed to minimize the hypoxic zones, or the maintain the species composition, and reducing the bloom sizes, all these type of things. And in general, it all boils down to 40% thought phosphorus reduction that are coming into these water bodies. It's a very general statement, but that's what it is. And the other thing that you have to notice is that we could not set any target for the East Basin. This has done through the ensemble modeling, like there are 7-8 models at that time, and Environment Canada has 2 models, and the other 6 models, 5 models came from the US side. Some of them are empirical, some of them are process based. Nevertheless, we were not able to set any target for the East Basin because we thought the science was not there completely to get there. The response was so weak, as you can see from with the load reduction. So that's one of the things that led to the new science plans. And now, if you see the next slide, this is what led to our new research program. So there are several things here that you can see. There is a lake and tributary monitoring. These are the priorities identified when we were setting up this one. Essentially reporting on those monitored loads at certain points in the priority tributaries, and also assessing the nearshore through this monitoring program. I just highlighted a box here where the science program or the research program has been there. For example, one of the key things is setting the East Basin nutrient objectives, or at least going there to set that one. And also do this work on an adaptive management framework. We also wanted to contribute to nearshore assessments and hypoxia. You can read through all these type of things. Then we also have a significant effort in the lake to look at the alternatives. Like we have phosphorus targets, but the questions came like, what's the role of nitrogen in the toxicity or the community composition? Then how do we report in real time? So remote sensing came into the picture. And then looking at some of the inputs from Thames and Sydenham and through Lake Sinclair, and how it is getting transported to the Western Basin. The last important thing is the late summer internal loading into the lake, as well as the transfers between the basins and nearshore and offshore areas. I will not talk about the climate change impacts here. I don't think I have time to do that today, but if anybody is interested, we can talk about it later. Sorry. The first one is this surveillance program, or annual surveillance program. Some of you might have heard the word CSMI, that is the Cooperative Science and Monitoring Initiative. We rotate each lake in each year to go back at, so it's a 5-year type of rotational thing. But in the lower Great Lakes, we have actually surveillance going on from Environment Canada 2 to 3 times in Lake Erie and 1 or 2 times in Lake Ontario. And you can see from this diagram, if you can see, there are some dots there that basically shows where the monitoring is done during springtime and summertime, or sometimes there are fall cruises as well. This is complemented by the US EPA. They have 2 more cruises, and they also do in the other lakes. So that way we cover the lakes in the offshore areas every year. This is led by our water quality monitoring group, Darryl McGoldrick and his team there. The second part on that A-based monitoring, which is, these are not really part of GLIPI, but they actually contribute significantly to GLIPI. So that's the reason why I'm trying to show this is a connecting channel project that Environment Canada monitors. We have regular stations that spans the data all the way from, in some places, 1970s, in some places in mid-80s to now. These are the stations like upstream and downstream stations, and a lot of parameters that were collected are similar like what we had seen in the previous slide, like nutrient concentrations, major ions, contaminants, and other things, and some physical parameters as well. So this gives us some baseline water quality status, and also to assess the trends that are required. The lower right-hand side, that I think if you can see this one, this is the work that is being done in cooperation with MECP and University of Windsor and others. This is Thames River monitoring and nearshore Lake Erie and Detroit River monitoring work that we have been doing as part of GLIPI to assist the modeling framework there. As I said, one of the tasks for us is reporting on the Canadian phosphorus loading. We have also contributing in developing the tool that is required for that one, the load estimator. That's based on David Dolan's earlier method. It's binationally used, so this is a consistent method of reporting on. In this particular slide, what it is showing is where the water quality monitoring is doing their regular monitoring work at 3 different stations from where the load is reported. These are done a little bit intensively, either weekly samples or sometimes we have ISCOs to do the time series. And if there is some rain event or something is happening, we target that, those kind of events and try to do more monitoring. So this is a busy slide, but you can see some of the key things here, like how they are reporting. For example, there is a red line there where that is the target line, like how much phosphorus is going to the central basin and how many times we are exceeding. And similarly in the Thames River. On the bottom corner, you can also see the sources of phosphorus and, in the loading computations. The key message, at least from my perspective, is that the sources identification is important so that we can actually target on what kind of management strategies one can develop in for those particular areas. So that's the key information that's coming out of this work. When it talk about the specific research project, I try to put too many things in one slide here. This is the first component that we are trying to address, looking at the effectiveness of the phosphorus reduction actions that have been going on in the basin. I think Sandy is going to talk a little bit more about it on the functional side of it. But here we are talking about the research side. We have 2 or 3 different types of activities going on here. One is from Patricia Chambers. She retired, and a new research scientist, Chris Parsons, has taken over some of this work. In the first one, they are doing it a paid watershed type of approach, which is essentially looking at one with less aggressively managed and one as a managed watershed, and see within the stream how the improvements comes. But the people who are working in these things, we all know that it's not that easy to see this effectiveness in the streams quite often. Depending on the hydrology of the year, and the variability is quite strong, and to get that we need long-term data to look these type of things. Right? The second component actually came to us a little bit late, mainly because of Chris Parsons came into the department. He started pursuing this work. He used to be in Waterloo, and from there he came here. What he is trying to look at is the phosphorus speciation work, and then looking at the Thames River loading, particularly the reservoir effect and the urban effects. I'm not sure if he has published the papers or not, but that's something that I need to ask him later in case if anyone is interested to look at that work. The last piece of work is to look at the groundwater fluxes into these streams. Jim Roy and Dale Stemford, they have collaborative projects with some academics to look at some of these aspects in the upper Thames River. They have collected quite a few samples during 2017 and 18 in some of these streams, and they have been quite active, but nothing much happened in the last year, and most probably not much is going to happen this year as well, but let's see what happens. Going from lake to the near shore, as I said, from the monitoring point of view, we have 2 aspects going on. One is monitoring of the near shore for HAPs and the other ecological aspects. But like I mentioned, our key thing is to get some targets for the East Basin, or get the science that is required for targets in the East Basin. Probably that's the best way to put it. In the East Basin, the issue is Chlorophora, as many of you know. And one key thing that missed in the last piece, last time when we were doing this work, was we didn't have enough information, particularly the time series information, to look at the model performance and also constrain the model outcomes to get this load reduction aspects. So we started working on this. Dave Depew works on this work with the monitoring division again, Megan and others, to look at some diver-led sampling traps and also high-frequency sampling, like I was just mentioning. So this is a key data set for our next set of modeling work that we are doing. The next one actually shows very quickly about the work that is going on in the lake, mostly sampling through the limnas at the stations that were pre-selected. There are two components here. Arthur Justepa and his team does this both in Lake Erie and Sinclair. They look at the potential changes of this phytoplankton and bacterioplankton community composition and toxin production type of things. They also did some nitrogen amendment experiments to provide insight on toxic production, and some of that data is coming up for a publication. And the other component of this one is we also are working with Maria Dietrich in University of Toronto with grants agreement with the university there, where we are looking at the internal loading, particularly the in the central basin, where redox related loading is quite important during the end of the season, during end of the summer season. So some of those things are being worked out, and we also linked this work to assess the interbasin transfers and nearshore offshore exchanges of phosphorus, and how that would impact some of the work that that's going on in the nearshore. I think I'll just mention this one. I will not go into details, but this is the product that had come out. This is remote sensing work that is led by Karen Binding in our team. She used both in situ data and optical data from the satellite sensors to look at developing some algorithms where the information on the community composition and reporting on the algae blooms. So that's the key here. We have to report every year or every 3 years, I guess, on the status and trends. And this is one piece that is being used. Similarly, US has their product perhaps, and these two are used together and complement each other in getting the algae bloom index reporting. So this data is available in near real time, and one can take a look at EO Lake Watch if you guys are interested to in this particular topic. Okay. So that's about the research component or the field-based work, and I spent some time on discussing about the modeling work as that's the key focus of the Lake Erie, Lake Sinclair work for us. I think we all know about the issues in different basins. This diagram essentially is taken from one of the papers from George Arahat and his team. After the ensemble modeling and setting the targets was done, there were lots of exercises done by many people, including us, in evaluating what these models did and what were the deficiencies and how to improve those models for an adaptive management framework. And some of the things that we started working on are adding processes, are developing new models. So that's what the topic today I'm going to discuss a little bit. For example, we started developing the watershed models using the SWOT model or CAN SWOT model. I'll just show an example there. And then we added winter processes, some of the winter processes in the one of the modeling framework. We also try to add, are still adding the sediment agencies. We are nowhere close to that one. But the hypoxia issues are being addressed through the impacts of the episodic events that I will talk about. And then we also looked at the key thing for us is the East Basin. As I said, the key processes that were not really addressed at that time are the mussels that are not part of the actual modeling framework. So we added the zebra mussels, and we also brought in the Chlorophora, whole Chlorophora modeling framework within the prediction system. So, the modeling framework. So that way we were able to address this at the same place. So all these things are part of this adaptive management framework that that probably is going to be a discussion in the next few minutes from Sandy as well. Just to give an idea of what we have been doing from the modeling point of view, as I said, this is an improved modeling framework. And one of the key things for me is to integrate all the research monitoring data within this framework so that we will have one place where we can look and look and assess these impacts, right? So there are several goals for this kind of integrated modeling framework. From the watershed side, of course, we are interested in looking at the assessment of the efficacy of these BMPs, and also look at the improved understanding of the processes. But the ultimate goal is to set the East Basin targets or look for the science that is required for the East Basin target. And also we agreed upon a couple of things in the adaptive management is that both countries will support their modeling frameworks and that would become the backbone for our future assessments. I will not talk about the climate change impacts, but as I said, we also have a short-term prediction system that I will just touch upon later. I'm talking this as an integrated model, but people can look at it in whatever way they want. This could be a linked model in a way, like the watershed models providing inputs to the lake model, and then that gives you the outputs and scenarios. But we are also using the same framework to go back in the reverse loop, as you can see from here, so that we can look what are the hotspots and where we need to do actions. And then if we do that, what happens in the lake and will we reach the state or not? So this process is continuous and the assessment happens at a fixed time frame so that we will be helping the adaptive management that way. Nancy, you can stop me if I'm going slow, or if you want me to stop anywhere, it's up to you anyway.
If you can wrap up in the next few minutes, that'd probably be great.
Yeah, I'll try my best. I don't know how many more slides I have, but this is one work that so I'll just quickly go over this one. This is the CAN-SWOT model, which the improved version of SWOT model, I guess that's what we call it. We had the winter processes included. We have running it for all the three watersheds that are identified for this particular lake issue. One can see that the phosphorus loading from these three tributaries and why we targeted those three as for this modeling purpose. It doesn't mean that we are not reporting on the other ones. We are reporting to the measurements and the usual load estimator thing that I talked before. Just a quick result summary. I don't really want to call this as hotspots, but these are phosphorus yields in these watersheds, and this also includes the point sources. So that's why some places shows up at much darker scale. We also looked at what kind of percentage reductions or what kind of actions are required to get those 40% load reductions from these things, and where we can achieve those type of things. So there are some listed BMPs there. Obviously, this is an incomplete list, and also there are other things that one can look at. This is just one example of what we have been doing here. I'll just spend 1 minute on lake modeling component. We have actually two lake models. One is the Alcam-Kadium that was used in Annex 4 work when we were doing. And also we have, that's a structured grid model for the hydrodynamics. And then we have an unstructured grid model, TU flow AED2. From the ecosystem point of view, both models are similar, but from the hydrodynamics or the basic engine drive is different in this, a little bit different, but the theoretical arguments are similar anyway. It does take the components of all the processes that are required, like the nutrient cycle, the metal cycling, carbon cycling, and some of the sediment dynamics that I explained, and how we incorporate this phytoplankton functional groups. We have zooplankton, but we never really did anything with that. And then as I said, we did zebra-mussel inclusion into this framework. Currently, the model has, both models has two different resolutions. The Alcam-Kadium has 2 kilometers in the horizontal and 1 meter in the vertical, and the other version is 600 meters resolution, but the unstructured grid has high resolution in the near shore and drops off as you go offshore. And both the processes in the East Basin that I said have been integrated within the modeling framework. So you have a complete system, at least for this for the purpose of this work, that's what we have right now. I will not discuss a lot, but just to make a point here that these are large lakes, and the hydrodynamics or the circulation dynamics actually drives most of the things that we see at the near shore or at different places. The nutrient inputs is one thing, but how that is mixed and how that is transported, and where there is a stagnation areas or where they are moving, all these things results in where you are seeing the blooms or even the hypoxia, for example, in the central flat basin. The stable stratification and the warming of the bottom layer actually increases the hypoxic potential. And once you have that, how it transports to the near shore and resulting in those fish kills or the closures and other things that we are talking. So this is very key component, and we have both model framework as well as several observing moorings to verify and input into those models. The second component is obviously the mass balance of phosphorus, where this is coming from, the tributaries, the internal loading, and I lost the screen.
Yes. Do you want to try hitting the share screen again?
Yeah, I'll try. Not sure why, but.
Yeah, I'm not sure what happened. That doesn't usually happen in Zoom. If you need me to share, I can try to do that as well. Just let me know.
I'll try, but anything happened?
Yes, it's working. There we go.
Okay. Sorry about that. I don't know. I'm not very much used to Zoom thing, but
No worries. No worries.
Yeah.
We're back on track.
Okay, good. Don't know. Sorry. I want to get rid of this one, but it's not working for me. Anyway, I'll go through these ones. Yeah. Okay. I forgot what I was talking. Anyway, we have 8 priority tributaries, and the loading comes from them. Some of them, as I said, comes from the models, like the SWOT models there. But some of them are also coming from the observed estimation of loading to the lake. And once that comes in, we, as the hydrodynamics moves it around, we look at the mass balances. The thing that we are doing since 2008 is the base year. From that time to 2016, we have completed this multi-year runs and seeing how these mass balances are and where the hotspots are within the lake, and the movement of phosphorus from one location to the other location. This is something that I wanted to mention about how the nearshore is being impacted by the offshore waters. I think many of you know that central basin of Lake Erie goes anoxic almost every year, hypoxic, but some years it can go to anoxic too. And a large portion of it is under this stable stratification. So we don't really see a lot of it on the in the nearshore regions, but once in a while, when the winds were blowing favorably, like for example, these upwelling events or the rotating Kelvin waves, bringing in these hypoxic waters and associated issues with that to the near shore. So we do see that's an important part in the central basin. But the other thing that we observed is similar kind of things are happening in the East Basin as well, and that has actually resulted significant input of nutrient fluxes to the near shore. So this has complicated the story of setting the targets, right? Like when we have the external loading target from Grand River, that doesn't really influence a lot of reductions. I mean, the reductions in the Grand Rivers are not really influencing a lot in reducing the Cladofora. That's one of the observations that we made some time ago, where we attributed it to some of the fluxes that are coming from the offshore to the near shore. Those phosphorus fluxes are almost constantly coming with these wind-driven circulation. So this is being added as another parameter in addressing those kind of relationships. We are also looking at, since 2008, as I said, as an adaptive management kind of thing. We have 5 functional groups model, as well as a 3 functional group model, to look at some of the load response questions, whether those empirical models that were used, some of them are empirical models that were used in the ensemble model, are holding up or not. And as you can see from here, the new data is still reasonably explaining the loading, external loading versus the bloom sizes and bloom sizes and the chlorophyll levels, for example. We looked at both total phosphorus and dissolved phosphorus and their links, particularly in the Western Basin. We're still doing some work in the Central Basin hypoxia story on the same thing. Whether if we reduce the total phosphorus, are we going to get, and how long it is going to take us to get there, those type of questions. I'll not talk much about the Chlorophyll growth, because this is kind of a dated slide. This has been included, as I said, in the unstructured grid modeling framework. Within the modeling framework, this is an earlier slide that has both muscle impacts and the growth that comes with that one. These are very preliminary results showing some of the Chlorophyll growth is picking up reasonably well, and we are also looking at each individual process and to assess if we are getting the results for the right reasons, or are we getting the results for over parameterization or over fitting of the curves. So that's something work is ongoing. Sinclair, if actually I got the same number of slides that I had right now for Sinclair, but I just tried to put it in one slide, saying that exactly the same 2 models, both unstructured and structured grid models, have been implemented, and all the data that was collected through monitoring programs from ECCC and MUCP and also University of Windsor has been used to verify and set these models up for different purposes. Some of the verifications right now had been for hydrodynamics and some pathogen transport and some simple parameters, but we are still trying to do the total phosphorus concentrations and the sedimentary load versus external load into the in the lake, and how that is exporting out of the lake to the Detroit corridor. I will not take much time, but I have the link here if anybody wants to take a look at this one. I just wanted to introduce that this system is there up in the real-time forecasting from ECCC for almost now 3 or 4 years. What this is doing is it's basically taking the Environment Canada weather forecasting system, GEM model, at the global to downscales it to the regional version, and sometimes even limited area model. Right now, actually, ECCC is running a 2.5 kilometer weather model for Great Lakes region. That is directly being used for the hydrological framework, that is a mesh model with a water route included, where the river routing has been included into this. You can see that one, and that provides input to the lakes. The lakes have been included as a 3-dimensional model. It's a year-round simulations. So the forecasts are 2 to 4 days, and now it is increased to 15 days for some parameters, but most of the weather and lake state forecasts are still 2 to 4 days. And this particular system is operational, and it is available. Anybody that wants to look at the currents, temperatures, or whatever it is, the winds and other things as forcings to their own modeling frameworks. It incorporates all the available observations, radar sat observations, and in fact the ground radar and the stream gauges information into the simulation. So it has both for the model based thing as well as the analysis included into that to use it for our own purposes, right? So we use the system, and we are actually doing it further work on this to do the passive harmful algal bloom movement. We selected Lake Erie, obviously. And how it works is we incorporate the remote sensing that I mentioned before as an initial condition at a 0 hour, and we try to forecast it for 48 hours based on that particular thing. Here only the hydrodynamics is moving it around. There is nothing much happening from the ecological point of view other than the loss rates and deposition of those blooms based on the characteristics that we attribute it to. So that's the one that is going on, and we have that in experimental state, and we really don't have an operational that particular component, but that's something that we have focused, and we are going to get there. So I'll wrap it up here. Just want to highlight here where we can have opportunities for collaboration and discussion. For example, although our initial focus or the next few months focus is mostly about the East Basin objectives and how we get there. But from my point of view, there are lots of researchers, probably some of them are on this call as well, to talk about where we can integrate our work with some of the work that's already happening in your teams, like legacy nutrients in soils is one thing that many of you are doing. And then in-stream processes work, that's something that we identified as a gap in some of these watershed models, and how we will address those type of things. Obviously, this as we make more and more complex models, it needs more and more new information and new data, and it would be nice to integrate it and validate, even to look at some of the feedback loops, right? The other question that came to us is the winter process. Although we have some winter model running in the multi-year simulations, we really never validated any winter processes. They are there hoping that they are not predicting anything bad, but we really don't know what's happening there. We have some ongoing work on the climate change impacts, both on the storm frequency side and the loading issues, as well as some of the work that the increased temperatures and loss of ice cover and things like that, and how they are influencing HABs and hypoxia and stuff like that. So I'll leave it there, and if anyone has anything, I'm sorry if I'm taken way longer than I'm supposed to. Now I don't know how to unshare.
Okay.
So thanks so much, Ram. So as Sandra is putting up her presentation, maybe I'll shoot off one or two quick questions based on the list of questions that I've seen.
Sure.
So I think the first question was from Tom Sama, and this was about total phosphorus. So most of the results presented were for total P. Is dissolved P of interest as well?
Yeah, of course. Yeah, I think I tried to put one dissolved P thing somewhere. I don't want to go back to the slides, but of course, yeah, both are there in the story of total phosphorus reductions, right? And we are very interested, and we call that a soluble reactive phosphorus, of course, but.
And then there was a question from Karen, but I think Chris Parsons already responded to that question, so I'm going to skip over it. There was a question from Thai Fan. Has any work been done looking into the roles of iron in cyanobacterial events in Lake Erie or Lake Sinclair?
I will defer that to Arthur or his team if they want to really get some educated answer on that one. But I'm not so sure if they are there on this one call or not.
And so one last question from Zara, and her question is there any monitoring program for measuring P species in the hypolimnion of the Eastern Basin, or winter measurements?
Winter measurements, yes. The cruises that we do are, I just had the IJC meeting. This is one thing that came up there as well, Sandy, is how do we improve on the winter monitoring and winter process. So there are several issues involved. Offshore monitoring, the biggest concern for us is the safety question.
Yeah.
And we rarely go, but there was some winter work done. I forgot the years, but there are a couple of years ago, we had the winter cruises, and we did in the East Basin, hypolimnion, several speciation work and other things that Alice and her team did. In the last 2 years, we didn't do any winter work, but this has been coming up a lot.
Thank you so much. I think that's about it with questions for now.
Okay, Sandy, do you want to take it from here?
I can do that. Okay, so like Ram, I've had to focus this presentation, and of course you can hear my phone in the background, and the dog will bark in a minute as well. So that's just going to be how that's going to be. Anyway, so what I've chosen to do today is to talk about adaptive management, how it's playing into our domestic process. There's a whole other process that's going on for the binational aspect of this, and they're distinct and connected. So the binational piece of this is really focused on the in-lake responses and taking the tributary reductions and trying to articulate or demonstrate what that means to HABs and chlorophyll and hypoxia. Whereas the domestic processes are really responsible for achieving the 40% reduction of their external loads. So they are quite different. Their focus is different, but we need both in order to kind of achieve the outcomes that we want. And I didn't have time to kind of deal with both, so I'd be happy to come back and talk about the binational aspects of this as well, if anybody's interested in. So right now I'm strictly focused on the Canada Ontario piece and how we're working towards, through an adaptive management process, towards achieving our goals. So Ram already went through this. We've got 3 responses in the lake, depending on where you are. And the other thing I wanted to really point out, and Ram did this as well, as Lake St. Clair is included in this. And from a Canadian point of view, we are also trying to resolve the nearshore blooms that we see in Lake St. Clair, which are significant from time to time. So just for context. And I guess the other important point here is really around where we've been and where we need to go. So if you look at the loadings here, we all know that we've been in this business for a long time. And in the 80s here, we took a big swing at reducing loads from wastewater treatment plants, and we're highly successful. And after about 85, you see they've gone up and down and up and down, but largely have remained very stable, even when we've seen significant growth in some areas, like in the Grand River. So these guys are doing a really good job, and you can see that most of the loads here are actually coming. This is the blue and the gold color here. Most of the loads are actually coming from non-point sources. And for Lake Erie, this means largely agricultural non-point sources. The red are towns and communities. This is City of London, this is Windsor. But for overwhelmingly, most of our point sources are coming from agriculture. And so it's no big surprise that this is where our focus has been. So when we talk about adaptive management, we're really talking about where do we want to go and where do we want to kind of end up. So it's with that in mind that we've kind of trying to design these processes. And as Ram spoke earlier, we have a number of agreements. I didn't put the Canada-Ontario one in here, but we have the water quality agreement. It drives the content of the Canada-Ontario agreement. And then we have the Lake Erie, the Canada-Ontario Lake Erie Action Plan, which is really our phosphorus reduction plan to meet our targets, Canada's targets for phosphorus reduction in support of Lake Erie. So one of the big questions is, how are we going to meet these loads? And that used to be fair. It sounds like a very straightforward question, but it is super complicated. So this is actually a simplified version of a very complicated process that's going on here. So lots of different things to take into consideration as we're trying to even decide how we're going to measure phosphorus load reductions beyond just the outlet of the Thames River, the Sydenham River, or anything else, because there is a real need to kind of understand the impacts of our actions well before you get to the mouths of these rivers. So it's a hugely complicated process. So in the plan, we have 128 actions. They're focused across these 5 theme areas, and they include everything from actual projects or programs more than likely to reduce phosphorus loads right through to improving leadership and coordination. And part of that is a commitment to adaptively managing this issue into the future. The other thing I would say about this plan is this really is a combination of where we are when we wrote the plan. So it encompasses things like existing legislation and policies. It was the projects and programming we had on the ground for implementing BMPs and other activities. It's science that we had on the ground, education awareness, and we have developed some new governance mechanisms to help manage this. But really, this was our first crack at just articulating what we're currently doing in support of phosphorus reduction and getting us to a position where we can understand what the impacts of that are and then move forward from there. And we're doing that through an adaptive management process, which is really all about understanding what we're doing, understanding what the outcomes are, how they relate to our objectives, and changing or intensifying our management actions as needed. So from an adaptive management point of view, we're now involved in 3 different projects that are largely being contracted through ECCC, but I will point out here that they're being managed by our adaptive management team. So this is work that's being led by us because we're doing the contracting, but it really, all the content and the further development of these products are being done by our adaptive management team, which includes partners from across the, from a wide range of folks that are participating in the implementation of the plan. So I am talking about it from an ECC perspective, but without these folks, we wouldn't be nearly where we are. So the first thing is kind of inventorying what we don't know. And this has become really clear that, you know, we know some things and we know that we don't know some things. And the real scary part is what we don't know, we don't know. So we are trying hard to put some structure around this so we can really get a good sense and a consensus around what it is we really do know and feel we can act on, and what is out there that remains significant knowledge gaps that we need to fill, what the implications of those are. So we right now have a contract that's out. We're calling it a phosphorus synthesis contract. And this is really going to provide a lot of the foundation for our work going forward from adaptive management. And we're working around a number of theme areas, and we're looking to and consulting experts to develop a consensus, a scientific consensus about what we know about each of these theme areas. And as part of that, we will be developing these conceptual models, which will actually schematically represent the consensus. So this is a big contract right now. It's being ESSA Technologies is helping us with this, and there are a number of people who are involved in this, and I would imagine a number of you who are participating in this webinar are involved in this or have been. We've reached out to you as a part of a survey and or participating in a series of expert workshops, the first of which is going to be happening at the end of this month. So we've, as I said, we've done the survey, and we have, So we've conducted the survey, and really we asked people, I can't see the tops of these slides, so I'm going to be guessing what this is, but we're asking people, you know, what are the most relevant, in solving the Lake Erie problem or the Lake Sinclair problem or reducing phosphorus loads, what's the most relevant issues, or what do we think are the most important issues here? And you can see the blue is what we survey respondents have come across as being the most relevant, and then the red is where people think they are the least relevant. And you can see that, you know, a lot of the agricultural activities around livestock and crop and greenhouses, for us, urban and rural drainage, you know, are all coming out as being relevant to managing these issues in the long term. I just need to get rid of this. How do I get rid of this? Oh, I didn't want to do that. Sorry about that. Okay. Okay, so the next piece here was around, whoops. Okay. So then we asked folks about what kind of the, can you actually, I really need to see the top of this screen here. How do I get rid of this bar?
I'm not sure, Sandy, but I could read the question to you if you'd like.
Yeah, can you read the question too?
You can just drop in, you can drag it.
Down?
Like grab it with your mouse and you can drag it to another part of your screen.
Ah, okay, so I can do that, okay.
From experience.
Yes, Zoom is not my thing here. Not that it really wants to go anywhere, but.
Or you could maybe try closing the box?
Yeah, there's no close.
Okay.
I get an option to leave the meeting. Okay. Okay. So, you know, you're seeing at the top of this list here that this is question 10. So there were a number of intermediary sort of questions for folks, but we're really, you know, this question was around what are the intermediate endpoints? Because as I said, there's a long way between what we do on the land and the lake. So what do people feel was the most important or the most kind of relevant intermediate endpoints? And once again, you can see landowner behavior and BMPs at the top of the list. And then as we go progressively downstream, things like nuisance algae, hypoxia are least relevant from the purposes of management, right? Like we can't, you know, we're taking a lot of management actions, but having intermediate endpoints that are actually the cyano, they really are long-term endpoints. They're not the interim endpoints. And then we asked a series of questions around what kind of degree of control or that people think we have. And so with the blue being and the black being really, you know, mostly within the influence of natural drivers or non-controllable, and then the red being most controllable or most under the influence of decision makers. And you can see that BMP adoption, you know, soil health, you know, some of these other things these three here are coming up as being the most, the land managers being most able to influence these sorts of things.
I don't think the slide went forward, Sandy.
Pardon?
I don't think that slide you just talked about is on the screen for us.
Oh, okay, it's on the screen for me. So what are you looking at, Nancy? What screen are you looking at? I'm looking at question.
We're on question 10.
Oh, okay. So why does that not happen? Okay. Okay. Are you seeing any advancing here?
No.
Oh, okay.
I wonder, try stop sharing and then resharing. I'm not really sure.
Are you seeing enhancement? I probably. Okay. I will try that again. Okay.
Apologies.
Mm-hmm.
Usually Zoom is pretty solid.
Yeah.
Today it must be a messy day for Zoom.
It was a really messy day for me. Anything, but so what screen are you seeing?
We've got question 10 still.
Okay, so it's gone back up. Okay, so let me see. Are you getting 13 now?
Yeah.
Okay. Okay, thanks, Dorian. Anyway, so then we asked a series of questions about, you know, what degree of management control, and you can see here that, you know, we really do have. There are a number of areas where people have a high degree of certainty that we can actually manage, and then others that we feel are more at more uncontrollable directly by land managers. So that's driving some of our results going forward. And then the last one is, what is our level of uncertainty? And once again, we've got a fair amount of uncertainty around some of these things in the gray and the black, and then the red represents more certainty. So we're talking about, whoops, okay, here we go again. Okay, and so once again, this will drive some of our questions and where we need to go with this particular exercise in terms of making recommendations at the end. Okay, so the other thing that they have been able to do is develop this hierarchy of objectives so that we have, you know, our overall primary goal, and then the ecosystem objectives, which are actually outlined in the water quality objective. And then there's a series of management objectives. So these will all feed into one another and relate to one another, and super important to understand how these things relate to one another as we move forward. And obviously some will be more important than others. Oops, wrong way. That's my fault, this one. Okay, the others, so the next thing we're doing is going into these expert workshops over the next period of time. And I mentioned the next one is in April, I think it's the 29th or the 30th. And out of this original survey information, we've got 6 themes that we're going to be working with. One around field cropping, livestock grazing, greenhouse production, municipal drains and runoff, natural areas, and landowner behavior were the 6 kind of main themes that came out of that original survey. And then for each of these themes, you will have a description, which will, you know, really characterize how each of these themes kind of operates in the Lake Erie basis in terms of definition, what areas are these particular activities occurring, what is the biophysical landscape, what are the socioeconomic aspects, and some of the socioeconomic aspects of a lot of these things are becoming as important as the environmental ones, and so it's really important that we make sure that this is included. We have what's driving the decisions, whether it's policy, local actions, individual actions, those sorts of things. And then we have a series of preliminary questions that we'll be asking the workshop participants. So this is the point where you decide whether you're coming to the workshop or not, which we'll need to answer for each of these things. And I'm not going to go over them, but we're really trying to describe kind of the characteristics and under what conditions do these things actually occur in the Lake Erie basis, and what's the relative impact and risk associated with them. So, you know, so this is just an initial set of questions for the field cropping theme, and our consultant is working with these. So this project is going to you know, continue for the next year. I think they're due to wrap up in March of next year. And so if folks are interested in participating in this as you know, as an expert, don't hesitate to let myself or Nancy know, and she can forward stuff forward. There'll be lots of opportunity for people to provide input if they choose to. So the next project that we have had on the go is around best management practices, and you'll notice in the survey work, there's a fair amount of recognition that managing best management practices might be one of our best approaches to actually achieving our goals in the long run. But there's also a fair amount of uncertainty associated with those best management practices in terms of their impact and their application. So, so we have done a literature review, a fairly extensive one, and it was undertaken by Wenhong Yang from University of Guelph. And he really focused on where we had good scientific studies. So this is all published literature to the extent that it can be. And he looked at the 14 BMPs that we really are utilizing to manage phosphorus off the landscape. And you can see some of the ranges here are crazy. Like, and they get even more crazy when you're talking about dissolved or soluble reactive phosphorus versus total phosphorus reductions. But they, some of these are really, really broad. And that's because the literature covers a wide number of landscapes, different geographies, different crops, different landscape characteristics, different soils, all those sorts of things. So you really do get these very broad ranges in terms of percent reduction. And in some, it's just not maybe super helpful. So the next thing we did here is we took some more local information that we had available to us and reran some of the SWOT models out of his lab for a tributary in the lower Thames, using local information we had from the upper Medway and and some of the swap modeling that's been done in the Grand River. And you can see now that we've improved on these ranges significantly, and that they're all positive, which was actually really good news, because if you went back and looked at the conservation tillage from the old one, from the literature review, you're getting negative numbers in a lot of cases. But if you move forward and you look at conservation tillage using the more local information, we get better information for sure. So all of this is in our report that we're happy to share with anybody who wants it, but will also be used as part of our ongoing activities in trying to describe or understand and come up with a standard approach to estimating phosphorus losses from practices that we're putting on the landscape. It also goes into our next piece of work that we're doing, which is around modeling. So modeling is a key component of adaptive management, and developing a modeling framework and operationalizing it is going to be super important. And so the next few slides are really around watershed models, but there's a strong connection, or needs to be a strong connection, to a lot of the modeling that Ram was talking about, and in terms of the in-lake modeling. And there also has to be fairly strong connections with some of the socioeconomic models that are out there. So recognizing that, we engaged George Yerubandi lab out of University of Toronto, and he's done 2 or 3 contracts for us around this, once again managed by our adaptive management team under the Lake Erie Action Plan. And so we've done a review of models, and for the purposes of really understanding what they are and what they represent, how BMPs are represented in these models, identifying the uncertainties associated with them, and trying to come up with a way of including the ecological goods and services aspects of it. So their lab looked at 11 different models. Most of these will be super familiar to most, if not all of you. And some of them are strictly agricultural, others are hydrological, and then we have the ones that are do the combination. And then they really spent some time kind of identifying what the strengths of these models were, and also identified the weaknesses in some of these models, so that we knew exactly what models were good for what and where the limits of their application were, which has often been a bit of a problem, because we get some of these models being stretched a bit in terms of their utility and use in terms of what they really should be used for. So we've got some very, very good advice on that, and as single models. But as I mentioned, we're actually looking to develop a modeling framework. So this slide just describes the range that you get. You get some models that are super simple over here on the, and just a second, okay. On the bottom scale here, or on the bottom axis, that you run from simple to complex. And then the blue is all the hydrological. The green are models that represent both hydrology and nutrients in their framework. And then the agricultural ones are the ones in orange. So you run from simple to more complicated, and then whether they actually deal with phosphorus, nitrogen, and or carbon. So this is a fairly simple graph, but it's got a lot of information in it. So they have definitely taken a strong look at the fate and transport. And once again, where are these models best applied? And then they've provided a number of summary tables that really look at, all the characteristics that I was just talking about. And some of the things that really show up here that we know are important, like in-stream phosphorus. How is it being moved through some of these landscapes? And a lot of these models, they do not represent it very well, or they use empirical information, and some of it is really sparse, to say the least. So some of the key questions we had for the development of this framework is, what are the technical strengths and challenges of the modeling framework? We have to kind of really identify what the realistic expectations are for the framework. What would be success in terms of what would that look like, and defining some criteria around that. Where we see uncertainty, does it provide meaningful information, or is it not particularly meaningful at all? And once again, how do we incorporate or associate what we're doing through a modeling framework with some of the ecosystems, other ecosystem services and socioeconomic values. And so we're looking at kind of two different, they looked at two different sort of frameworks. One is this input of one model goes to the second model, goes to the third model, or alternatively looking at an ensemble where you've got model 1, model 2, model 3 pulling, you know, all providing an ensemble perspective on the issue at hand, which is phosphorus reduction. And you get a single output from all these models. And so we're also looking at different scales. So they looked at basin models, which is right now the Sparrow model is the one that they have. Then there's a number of watershed-based models, and Ram talked about the SWAP model, but there are a couple of others here that are, and then we have these field-based models as well. And then integrating that and being able to associate it with the lake models or an EGS model as well. So they had some good recommendations around that. And I think the idea has been they've recommended 3 different ensembles. One, and I'm not actually going to go through these and just because of time, but we've got 3 different models moving forward from an ensemble point of view that are up for consideration. And they get increasingly complex as time goes, as we go forward here. But our technical teams are going to have to take a look at these and see what they come up with. So some of their high-level recommendations is for a modeling framework is the watershed modeling has to be the core of this. And remember, we're on the land side of this. So we really do need a watershed modeling as a core from a spatial scale point of view. We need to be really focused on leveraging expertise across government, academia, and industry. Everybody has a piece of this. And it also maybe becomes more important as we talk about the governance going forward, because, you know, Environment Canada has models and MAFRA has models and academia has models, and we know that because we've worked with everybody. But then, you know, how do we actually operationalize this framework has been a key question. Also associated with this is whatever we come up with, we've got to be able to train people on, and it has to have a wide availability and use. And we need to really understand what is underrepresented in these models and what risks may be associated with that. And the last thing, which we need to understand the data requirements and the availability of data that are associated with these models. And as part of the contract, George took a swing at this. So we do have some of that initial information on what would be the data requirements and availability to maintain any one of these recommended frameworks. And as I mentioned, the governance and the sustainability of this framework is probably one of the key issues going forward about how do we make that happen. And just of note, it's the same problem binationally as well. We're going to be looking at the maintenance of at least 2, if not more, whole lake models. And, you know, how do we make sure that they continue to exist into the future? And then the next piece that's coming that we have under contract right now is a cost benefit analysis. So looking at the BMPs and other activities, how much is it going to cost to implement the actions that we need to take to achieve our 40%, but also what do we benefit from that? So there's a number of additional benefits that have been identified that run kind of right through from you know, economic benefits right through to climate benefits that are associated with this. So we'll get this, the results of this in about a year, and that should prove to be pretty interesting. So our near-term next steps are really this science synthesis that we are moving forward with that I spoke about initially. And as I said, if anybody wants to be involved, just contact me or Nancy and you can get hold of me. We need to really create this technical subgroup of the adaptive management team so that they can look at the results from a lot of this contract work on recommendations for the modeling framework and come back to our larger team for concurrence on that. Once again, I think there's definitely opportunities if people are interested in participating in this in one way or another. I think there's opportunities for that. And then the last thing is here is looking at data availability. We know what we need, but what's out there. So that's our near-term next steps going forward here. And I think I just want to recognize that we have a number of partners here leading on the implementation of the plan are the 5 agencies. 2 federal, ourselves and AAFC, and then the 3 provincial ministries. But we have a number of other groups that are participating in the implementation of the plan and actually have actions in the plan that run from all of the conservation authorities in Lake Erie right through to, Alice or the greenhouse growers, those sorts of things. So it's a pretty broad group, and we have lots of work to do. Anyway, I think that's it. So any questions?
Thank you so much, Sandy. That was really, really informative talk. Really enjoyed it. So we have a few questions in the chat, and I think there was first question Tom asked, and that I think was already answered. So I'm going to move on to the next question that I had asked, and there's a conversation around it. So this is a question about the SWOT model. So you started out talking about the meta-analysis, the data, and it showed that implementation of BMPs can be from negative to positive effect. And then there was a SWOT model that said, well, now it's positive, it's all positive, and it's constrained. So the question is for me, the question is, in a SWOT model, there's no way a SWOT model will say that a particular BMP will lead to a negative effect, because that's inherent in the equations of the SWOT model, right? And I think Tom asked a question about that are we correcting for data by using a model? And I'm a modeler, but I have this. Right?
Don't ask me that question. Ask Grant that question. I'm not a modeler either. You got what I knew.
Right. I know. I mean, this is a broader question. It's a little, and I think Natalie asked to that a clarification whether the model was constrained by empirical data in the Medway and Grand River watersheds.
It will, it will be to a certain extent, for sure. So I would have to go back and ask Wang Hong about the details of that. I don't think he's on this call today. So I can ask around that, but I suspect that it definitely was,
Can I ask a follow-up question in that context? Is there, so as I said, I'm a modeler, but I do not trust models because I know the equations in the model too well.
Yeah.
So is there data being gathered in terms of BMP effectiveness at the field scale? And that could be a part of a meta-analysis that's a more constrained than a global meta-analysis.
Yeah, and I think that, I think that was in part the point I was trying to make, is they did use local information to, out of the Upper Medway, some of those field trials, as well as some of the more localized information that went into that Grand River SWOT to help inform that next piece. And the whole point is that it's really hard to take that literature value and apply it anywhere, right? So so I think there's a number of projects out there right now that are looking at BMP effectiveness. That I think a lot of and Dorian's on the phone, so she could probably speak to the on-farm sort of activities. Our piece of the Great Lakes Protection Initiative has a monitoring and evaluation component to it. So any projects that are on the ground, they have to come back with monitoring and evaluation component. And we're really hope that, and some of those sites are the exact same sites as the glassy sites were, the OMAFRA program from the past. And so we're hoping for good long-term data sets there. And I think the place where it seems to be landing the data anyway is in Whiskey, because the conservation authorities are largely the leads on a lot of these projects. So I know Karen's on the phone, and I know Dorian is on the phone, so they may have. So how we take that information and inform kind of our modeling efforts is the next question.
Okay, so this also addresses, thank you for that. I think this also maybe addresses Jim Roy's question, which is, have any of the SWOT model prediction been tested against BMPs using field data in that area?
And so I would defer to Ram a little bit about that, because it's his, or people who are actually doing the modeling.
I can add a little bit, but I'm not going to say much. If you are in the modeling business for too long, you will become too skeptical about the whole modeling business, right? So I'm spending almost 25 years in this. I keep questioning about some of these formulations. I think I will agree with Nandita that the key thing is that the model is not meant to say something that is not there in the model already, right? So that if somebody is talking about DP and if it is not there, the process exactly the way it is, then I'm not so sure if it is going to be addressed, if that was how it was framed, right? The other thing about whether the models are validated, both Grand River and Thames, most of the validation of the models is only about the current loading and current aspects, but at a field scale level, when the BMPs are actually being implemented, this SWOT is not the answer, because SWOT is the answer only at the point where the calibrations took place or where the validation point is. So, but there are so many model validation exercises with SWOT at many different places. We also did a few in the Great Lakes and Lake Winnipeg Basin. But for this particular exercise that you talked, Sandy, I don't know what George has looked at and what literature he has looked at, but for Jim's question, not everywhere, but some the typical non-structural and structural BMPs and how they perform and how that is assessed has been looked at. Obviously, it has to be at a very finer scale if you apply that. If you apply at an HRU scale, I don't think we can really say much about it.
No, true enough,
Okay, I don't see any other questions. Can I ask one other question? I'm hogging on the question time, but this was really nice, really interesting presentation. So my other question was that I was noting down the expert opinions, and one of the, I think the second one of the list was livestock management. And some of our mass balance work also highlights that manure is one of the biggest components of the mass budget. So my question is, are there thoughts on paths to that excess manure? Think about manure to biogas as possible options, and management of that manure at a larger scale as one of the.
I would ask Dorian or Natalie to speak to that, because they're more involved in that. I've had some contact with some folks, but really that's not our bailiwick so much, right? So Natalie, are you there, or Dorian? I can see, there she is.
I am, but if Dorian wants to take this one, she's welcome to. There are a lot of efforts on the way to for proper manure. There are a lot of manure management, BMPs. There's the Ontario Nutrient Management Regulation, of course. That's the backdrop, the framework for that. In terms of some, as with all of the BMPs, there'll be a range of efficacy. So, for example, manure to biogas, that reduces the carbon in the manure because that's the energy source, but there still is the nutrients in the manure. And anaerobic digestion, for example, changes the consistency of the manure. That may or may not make it more of a risk, because sometimes it makes it more likely to run off just because of the physics of how it changes, or not. It really depends. In terms of, and I don't know if you were asking this, but in terms of a geographic scale of manure management, I'm not aware of anything ongoing. So that's because as you anybody in Lake Erie, but I know at Nandita you're aware that there are different, livestock is not evenly distributed within the Lake Erie Basin. So there are areas where there's more manure and areas that there's less. So I'm not sure if I answered your question.
No, thank you. Actually, you did. And I might reach out. I won't take up any more time, but I might reach out and ask. Oh, Nancy tells me that we have to wrap up because our room is till 12:30. I don't think I see any other questions there. I would like to give a big round of applause. And Nancy had a quick comment. Sorry.
Yes, thank you. Our next meeting in this series is with Mel Loomis on April 30th at 11, I think. So yes, 11 to 12. So please register on the Lake Futures webinar website. And we look forward to continuing this conversation. Thank you very much for everyone for joining us. And we hope to see you again soon.
And thank you again, Sandy and Ram. This was really, really informative and really enjoyed it.
No, you're welcome.
Absolutely. Thank you.
Bye. Bye, everybody.
Bye.
Bye.
Bye.